All right, well, welcome to a question a day, and this is day 3. Find the domain over which this function is decreasing. Okay, so there's a few ways to do it. I mean, I can see straight away that because there's a positive number there in front of the x squared, that is, a is bigger than 0 in the quadratic equation ax squared plus bx plus c. Because a is bigger than 0, it's a happy parabola, so it looks like this. So on this side, it's decreasing, coming down here like there to the bottom, but not including the bottom, of course, because that's the stationary point. So all I've got to do is find the axis of symmetry of that parabola, and to the left of it is the part where the parabola is decreasing, going down as you move from left to right across the number plane. So I can easily do that by finding the axis of symmetry, which we know is x is minus b on 2a from your standard parabola. So that's minus of minus 12 on 2 times 2. So that's 12 on 4, which is 3. So anything to the left of 3 is decreasing. So x is less than 3. But if you weren't sure of the shape of the function, you would say, well, for a decreasing function, we're wanting the first derivative to be less than 0. We're wanting it to have a negative gradient. We can see that happening here, can't we? It's got a negative gradient. So if that's the case, we just need to differentiate the function that we've been given here. So we differentiate that and we get 4x minus 12. So we want that to be less than 0. So 4x is less than 12, so x is less than 3. So the answer was C for sure there. Okay, let's have a look. There's a table and they want an approximation for an interval. And it looks like it's a lovely increasing function. You can tell by the function values here. So we're going to assume that that's all going to work out very nicely to just use our trapezoidal rule. And they want the trapezoidal rule. So I'm going to write that down off the formula sheet for you. The trapezoidal rule says b minus a on 2n, and then it's got f of a plus f of b plus twice all the f of x1 in the middle. So that's what the trapezoidal rule says on the formula sheet. Well, we know that that's the right end x value, and this is the left end x value, and this is the number of trapezia, or the number of strips, or the number of sub-intervals, not the number of ordinates. You know, if you have a picture with, so there's our axes, and we've got these lines going up, they're our ordinates, right? Ordinate is the line going up. Well, we don't want the number of ordinates because there's always going to be one more ordinate than there are trapezia or strips or subintervals. All right, and A, so all we need to do then in that case is go, well, this picture, it doesn't really matter what it looks like, so I'll just draw anything. It's going from 0, and then it's 0.5, and then it's 1. So we can see we've got 2 trapezia created. So B is 1 minus A is 0 on 2 times 2 trapezia. Now function of A is function of 0, and then from the table that's 7.8. Function of B, the right hand endpoint, is function of 1, so that's 15.4. And then twice, and we go into the middle now, and there's only one ordinate in the middle that we're using, and that's 11.6. So that there will evaluate our answer. But just before I do that, I want to point out that if you know that it's trapezia, and you know for some trapezium that the distance between the parallel sides is 0.5, then you can use the formula for a trapezium as well. The area of a trapezium is just h on 2 a plus b, where h is this distance here between the parallel sides, and one of them is a and one of them's b, right? So I could have just said, well, 0.5 on 2, and I've got two trapeziums that I'm going to be working with. I'm going to be working with the one with 7.8 and 11.6, and also the one with 11.6 and 15.4. So just common sense and area of two trapeziums is going to get me there. But anyway, back to what I've got here. Both of what I wrote down the bottom would have a quarter, that'd be a quarter out the front. And then we've got 7.8 plus 15.4 plus twice of 11.6, which is 23.2. So I'm going to just put all those in, plus 7.8 plus 15.4. So it is a quarter of 46.4, which is 58 on 5, or 11.6 itself. So let's have a look up here at where our answers are and see 11.6 is our answer for that, our integral there. Okay. Differentiate. Well, I mean, if you want to, you can look at your formula sheet, because your formula sheet has the derivative. It says y equals e to the f of x, and the derivative is dy dx equals f dashed of x e to the f of x. So that's what the formula sheet says. If you've got that, that's how you differentiate it. So you can just follow that. If y equals e to the 5x, then dy dx equals, you've got to get the derivative of this f of x, so it's just 5, and then you want e to the f of x, so you want e to the 5x. So that's b. 5e to the 5x is the derivative of that one. Okay, and this is the last question we're on. A card is selected at random from a set of 100 cards, numbered 1 to 100. Find the probability that it's a multiple of 3. Well, how many multiples of 3 are there between 1 and 100? You know, like 3, 6, 9, all the way up to, and we know 99 because we know that's 33 lots of 3. So we know there's 33 of those multiples, and there's 100 cards. So the chance of getting one of those particular multiples is 33 ways of it happening out of the 100 total possibilities. So that's D. And that's the end of today's question of the day.